Hello guys, welcome to Bugs in Code. The problem that we are going to discuss today is avoid explosion. So let's move to the problem statement, and it says that Geek is a chemical scientist who is performing an experiment to find an antidote to a poison. The experiment involves mixing some solutions in a flask. Okay, based on the theoretical research Geek has done, he came up with a n cross 2 array mix where mix I equals x and y denote solution x and y that needs to be mixed. Also, from his past experience, it has been known that mixing some solution leads to an explosion and thereby completely ruining the experiment. The explosive solution are given in an array danger where danger I equals to P and Q, which says that if somehow P and Q get into the same flask, then it will result in an explosion. Help Geek by returning an array answer of size n, where answer I is yes if it is safe to mix solutions in mix, or else it is no. We are also given one example here, and I'm going to explain this example. So the example says that you have n equals to 5 and you have m equals to 2. So n is something which is the size of the mix array, and it is going to store 1 2 2 and 3 4 and 5 3 and 5 and at last 2 and 4. We are also given an array danger, and danger contains 1 3 and 4 2, means these two should not be mixed in order to avoid explosion. So what I'm going to do is, now I'm going to try to mix uh, each mixture and going to check whether it is safe or not. So for each value in the mix I, I'm going to, like, for each value in the mix I'm going to check whether it is safe to mix these two or not. So I'll start with 1 2. Mixing 1 2 is safe because 1 2 is not something which is present in the danger array, so it will not cause an explosion. After, so I'm going to write yes here. After that, when I try to so it is mixture, I'm going to write mixture here. After that, when I try to mix this 2 and 3, so it will be something like this. So when this 2 and 3 got mixed, then indirectly I have also mixed this 1 and 3. So this is not something which should be there, because if 1 and 3 got mixed up, then it will cause an explosion, as written here in the danger array. So I'm going to write no here. So this is not something which should be there. After that, here is 4 and 5, and 4 and 5 is something that can be mixed easily because it is not going to cause an explosion. After that, so I'm going to write yes here. After that, here is 3 and 5, and 3 and 5 we can mix easily, so I'm going to mix 3 and 5 as well. So I will write yes here. After that, for this 2 and 4, if I mix this 2 and 4, then it is going to cause an explosion, because doesn't matter whether I here doesn't matter whether I mix 4 2 or 2 4, both means the same, both are going to cause an explosion. So I'm going to write no here. So this is something which I should return. For each value I should return whether it is safe to mix it or not. So this is something which is going to be my output. I hope you guys got the clear understanding of the problem statement, and let me just now move to the solution part. Okay, so I'm going to write the same example again. The example says that we have n equals to 5 and m equals to 2, and we have given mixtures like 1 2 and 2 3 4 5 3 5, and one last is 4 2. After that, we have a danger array which contains 1 3 and 2 4. Now, the first approach that comes to my mind is very similar to the one that I was explaining in the problem statement. So what I can do is, for each mixture, I'm going to first mix, then check, then check. What this means? Let me write approach 1 here. Approach 1. So this is something which is brute force approach, because it's going to give me time limit exceed, and I'm checking all the possible ways that I can have. Like, first mix then check simply means that if I have 1 2, then I'm going to mix 1 and 2, and after that I'm going to check for each value in danger whether these got mixed up directly or indirectly or not. So how to check it? How to check it? Let me tell you. Each mixture I'm going to represent like mix is something which I'm going to represent with an edge. So I'm going to have an edge between two chemicals like 1 and 2. This means that 1 and 2 are mixed up, no doubt. After that, what I'm going to do is I'm going to check if a path is if path exists between any two numbers, then these are already mixed up directly or indirectly. Like if I have 5 here, then I can say that 5 and 1 are also mixed up. It is similar like I have water and I have sugar and I'm mixing salt into this. I'm mixing salt into this. So indirectly, I'm mixing salt and sugar also, isn't it? So this is similar to this example. So what I'm doing is if 1 and 2 are mixed and 2 and 5 are mixed, then 1 and 5 are also mixed indirectly. So this is what I'm going to do is like represent mixture, represent mixture using simply represent mixture using a graph. So edge means these two are mixed up. So now I can mix 1 and 2 easily. So I'm going to mix 1 and 2, and for each value I'm going to check whether path exists between these two and not, which means these are mixed or not, directly or indirectly. So 1 and 3, are they mixed? No. 2 and 4, are they mixed up? No. So this is not going to cause any explosion, so that's why I'm going to write yes for this. After that what I can do is I have this 2 and 3, so I'm going to mix this 2 and 3 like 1 2 and 3. Now for this graph, now this is my modified graph, and for this graph I'm going to check whether I have directly or indirectly mixed any of these value in the danger or not. So for 1 3 I can see that the path exists between 1 and 3. The path is similar like the path is this one. So this path is something which exists and this is going to cause an explosion. So what I'm going to do is I'm simply going to write no here, and after that, since it is not safe, so I'm going to remove this particular edge. So let me write the steps as well. So steps will be something like if path exists between u and v, so for every u comma v in like danger, if path exists between u and v, then it's not safe. And for every value, if I have found that no path exists, then it's safe. It's a pseudocode. It's not something that is that I'm going to write here. It's just an idea which I'm going to implement. So now what I'm going to do is I'm going to check for this 4 and 5. So this 4 and 5 are something which can be mixed, because if I mix 4 and 5, so there is no any value in this danger which got mixed up. So this 4 and 5 I'm going to write yes, and I'm even going to mix it. After that, for this 3 and 5 I'm going to like mix this 3 and 5. So let me write 3 here. After that I'm going to write yes here. After that, for this 4 and 2 I will mix this 4 and 2. Now when I check path for this one and I check path for 2 and 4, so I can see that the path between 2 and 4 exists. So this is how it is going to write no here. So this is about the brute force approach. I hope you guys got the idea what I'm actually going to do. So for every mixture, for the current mixture, for current mixture, so what I'm actually doing is for each value n in the mixture, I'm traversing m times the danger array. So I'm traversing the whole danger array which has the length m, and for each value I'm going to check whether path exists or not. So the length of path is something which depends on the density of graph. So like this can be large value. Why I'm saying large value? Because if I have a like graph of 5 nodes, then it can have like high density. So this like which can cause a large time complexity. So yeah, I'm even going to show you the code. So let me just move to the code for like the brute force approach. So this is the code for brute force approach, and the first step that I'm doing here is I'm making a graph. Okay, after that I have also made our answer array list. After that I'm checking all the mixture, and for the current mixture first I'm going to mix, and this is what our approach says, that first mix then check. And after that I'm going to check for each value in danger u and v if the path exists between u and v, like indirectly they got mixed up. So in that case I'm going to like make my safe equals to false, and at last and break, and at last I'm going to check whether it's safe or not. So if it is not safe, then I'm going to return the edge that I have created initially. So, and let me even show you the path exist function. So path exist function is similar function, simple function which you have seen in any graph problem, that I'm traversing, I'm going to each neighbor, and after that I'm going to check whether it's my destination or not. So this is what I'm doing in the brute force approach. Let me just even try to run it. So it's going to work, no doubt. And let's see. Okay, it's working, and let me submit it. But it is going to give me time limit exceed, no doubt. So it is giving me time limit exceed. Why? I have told you already that it is going to cause a lot of complexity because it depends on the density of graph. After that, this is all about the brute force approach. So let me move to my screen. And now the approach that I'm going to tell you is something which is approach 2 and optimal approach. So I'm going to write here approach 2. Now this approach is something which is totally different from the approach that I have done earlier. It says that first check, then mix. What does this mean? This means that for every mixture, for every mixture, I'm going to first check whether it's safe or not. So if safe, then I'm going to mix, else not mix. So just one thing is changing here, the way we mix. So what's different from the previous approach is the way we mix and the way we check for safe or not. So how it's changing, and let me explain you because it's really very interesting. So I'm going to write my mix again. So it was 1 2 and 2 3 and 4 5 3 5, and at last I have 2 4. And here danger, I have in the danger I have something like 1 3 and 4. Now what I'm going to do is I'm going to first I'm going to explain how I'm going to mix. Mixing means union. So the algorithm that I'm going to use in order to perform union is union find algorithm. Union find algorithm. And what I'm going to do is, like for this 1 2, I will simply mix it. 1 2 can be mixed. After that, for this 2 3, mixing here means that I am making 2 as a parent of 1. No doubt. 2 becomes parent, 1 becomes child. So this is something what the union says. After that, for this 2 3, what I will check is I will find the parent of this 2. Parent of this 2 is 2 itself. And okay, I hope you guys are aware of the parent array. Like first of all, I'm going to make a parent array. Parent array says that the parent of each value is going to be 1, like parent 1 2 3 4 5, and parent of 1 is 1, parent of 2 is 2, parent of 3 is 3, 4 is 4, and 5 is 5. This is something which is our parent array. And after that, what I will do is I will check for this one. So now the parent of 2 has become like parent of 1 is now 2. This is something what the union says. So after that, what I'm going to do is to check for this 2 and 3. And for this 2 and 3, I can see that the parent of 2 is 2 and the parent of 3 is 3. Clear. For every value in danger, I am going to find the parent, like parent of this 1 is 2 and parent of this 3 is 3. So if the parent are matching, then it's not safe. So like if I say that parent of like, if value in mixture is x and y and value in current value in danger is u and v, so if my parent of x double equal to parent of u and parent of like y is double equal to parent of v, then not safe. Okay, else one more condition that I'm going to check here is, let me explain you. It also may be possible that instead of this 1 and 3 we are given 3 and 1 here. Like if we are given 3 and 1 here, then what to do? Then the parent will be reversed, like parent of 3 will be 3 and parent of 2 will be 2. So I'm also going to check for that condition as well, that or if parent of x is double equal to parent of v and parent of y is double equal to parent of u, then also I am going to write not safe. Else it's safe. uh, Else it's safe for the current one, but I'm going to check for all the like values which are present in this danger array. So now what I'm going to do is, I'm going to give you a brief explanation about how this parent find algorithm works, union find algorithm works. And after that, but before that, I'm going to write that mixing means mixing means union, and check means find parent, find and check. So how after finding the parent it is going to check is, it is written here. So how to perform union, union is something when I have two nodes like 1 and 2, then simply make 1 as a parent of 2. So I'm going to make like 2 as a parent of 1. So it is what the mixing say. After that, if I want to mix 3 to this 3 to 2, so what I'm going to do is, I'm going to make like 3 to 1, so I'm going to make 1 as the parent of 3, no doubt. After that, if I want to mix like 4 and 2, so it doesn't matter whether you make 1 as parent of 2 or 2 as parent of 1, both means the same. And after that, if I want to make like uh, 3 and 7, so I'm going to make 3 as a parent of 7. So this is how it's going to work. But the problem is, if it becomes a skewed tree, then finding parent simply means, if I want to find the parent of 7, so parent of 7 is going to be 2. Like parent of 7 is actually 3, but we find the extreme ancestor from which the series is starting. So that's how parent of 7 is 2. So how I'm going to check the parent of 7? So I'm going to like move to the parent, then I'm going to move to the parent, then I'm going to move to the parent till my condition doesn't become true, that parent of I equals to I. So this is what I'm going to do. And if I see here, if it becomes a skew tree, then it is going to traverse a lot of distance in order to like find the parent. So how we are going to avoid this? We are going to, actually I'm explaining the union find algorithm here. If you are someone who knows the union find algorithm, then you can just move to the forward part of the video. So what I'm going to do is, if I have like 1 2 3, and if I have like 5 6 7, so there are two ways of combining them. The first way says that like if I have some like 4 is also here, so the first way says that make 5 as the parent of 1. So how I'm going to do is, I'm going to do is by like 1 2 3 and 4, and now 5 is the parent of 1, so 5 is here, and 6 and 7. Here you can see that the height of this is something which is increased. So height of this was having being 3, and now it's 1 2 3 4 5. It was 4 and now it's 5. The other way says that make 1 as parent of 5. So if I make 1 as parent of 5, so it is going to be 6 and 7. Now you can see that the height is same, height is 4. So in order to make the same height, I'm going to make the parent has the greater height. So greater height mixer will be the parent, and the smaller height will be the child. So how I'm going to achieve this? I'm going to have a parent array. So if you simply do just parent of like parent of I equals to like J, then you are also going to have the same answer. So instead of explaining the union find algorithm, I'm just going to show you, because union find algorithm is something which is a different part, and if you guys want me to make a video on that as well, so you can let me know in the comment section. So this is the simple approach that we are going to use to solve this problem. Let me just now move to the coding section. So I have already copied the code and I'm just going to paste it here. So this is the code for this solution, and we have a parent array and we have a rank array. So just forget about this rank array for some time. This rank array is something which is used to solve that problem that I have already explained you. So I'm not going to explain in detail in this video. And now what I'm going to do is I'm going to initialize my parent I as equal to I, and after that I have my answer. And for I equals to 0, for each value in the mixture I'm going to check whether it is safe or not to mix them. So what I'm going to do is I'm going to have parent for each value, and after that I have safe equals to true. Initially I'm assuming that it is safe. After that, for each value in danger, I'm finding the parent of that value and I'm checking the same condition that I've already explained you. After that, if it is not, when I'm done with all the values in the danger, so I'm going to check whether it is safe. So if it is safe, then I'm going to do union and I'm going to store like true. So instead of this union, because if you guys are not aware of how union works, so I'm going to write a simple parent of px equal to py. Simple. Now this is something which is also going to work. Let me just run this. After that I will explain you how we are finding the parent if you are a beginner and don't know about how it works. Okay, it says that I'm having repeated class, so let me just remove the extra stuff. Okay, now you can see that it's working, and if I submit it, it will also work. So this is something which is also going to work. If you guys know how union works, then you can simply use that approach as well. So you guys just don't have to worry about where the code I have provided in the description of this video. And now I will tell you how I'm actually finding the parent. So let me move to the screen. So how I'm actually finding the parent is I'm going to explain the same code. Like the code says that if my parent of I, like I want to find parent of I and I have parent array. So if my parent of I double equals to I, then it is simply I'm going to return I, because I is the final parent, because for the current value I don't have any parent is the same value itself. So I'm going to return I, else I'm going to move to the parent, like I'm going to return find parent of I and P. What does this mean? This means that if I have 1, 2 and 3 and 4, so in order to find the parent of 4, I'm going to ask from this 3, hey, do you know what is the parent of 4? After that, this 3 is going to ask from this 2, and this 2 is going to ask from this 1, and this 1 is something which has the parent itself. So it is parent, so this condition becomes true, and now I'm simply going to return the parent. So this is how the code works, and this is all about this video. This is the code, and I hope you guys like the video. If you like the video, then hit the like button. So till then, thank you.